Welcome to the session. Today we are going to discuss graph isomorphisms. So whenever any graphs will be there, what is the isomorphism condition between those graphs? So let us consider, we are going to take, let us say, G1 is one graph which is having V1 vertices, E1 edges. And G2 is another graph which is having V2 vertices and E2 edges. Then there is a function, let us consider the function from G1 to G2. G1 to G2 means, strictly speaking, this is vertex 1 to vertex 2 or vertex 1 to vertex 2. So such that the function, let us take the function as from vertex 1 of G1, vertex 2 to vertex 2 of G2, and if the function is 1 1 and onto 1 1 and onto function, and if there exist for all vertices A comma B belongs to V1, A comma B belongs to V1, that means for all pair of vertices in V1 and of course of G1, of the graph G1, then the edge, let us consider the edge I am going to take, AB belongs to E1, if and only if there is an edge f of A, f of B belongs to E2. Then we can say that the function f is isomorphism. Then we can say that G1 is isomorphic to G2. Let us once again, if G1 is a graph which is having these many vertices and G2 is having another graph which is having V2 and E2 edges, then f is a function from G1 to G2, or we can say that vertices of G1 to vertices of G2, such that if the function f is 1 1 function and onto function, then second one, for every pair of elements, for every pair of vertices in V1 of G1, suppose I am going to consider there is an edge, AB an edge connecting between two vertices, A comma B, so which is belongs to E1. So there corresponds another edge, there corresponds the image f of A comma f of B belongs to E2. Then we can say that the function is isomorphism from G1 to G2, and we can call it as a graph G1 is isomorphic to G2. This is mathematically, we can say this. Or equivalently, we can consider, you can say this definition in another way. Let us say the two graphs is said to be isomorphic whenever the four conditions are satisfied. So one is number of vertices in G1 and number of vertices in G2 must be same. Number of vertices must be same in G1 and G2. This is the first condition. The second condition is number of edges in G1 and G2 must be same. Then the third condition is the degree sequence. What is meant by a degree sequence? So degree sequence of a graph is defined as a sequence of the degree of all vertices which are written in ascending order. So degree sequence of a graph is defined as sequence of degrees of all vertices which are going to be written in the ascending order. So that is known as a degree sequence. That is known as a degree sequence. This is we discussed already in the previous sessions. Okay. Now, so here the degree sequence of the both graphs must be same. Must be same. This is the third condition. And fourth condition is if a cycle of length k, is formed by the vertices of one graph, then the cycle of same length are going to be exist in the other graph. So from this, suppose we are going to consider the cycle of length is k with the vertices v1, v2 and so on vk in one graph, then the mapping is the other graph is consisting same path length, same cycle length is k, and which is going to be formed by the vertices f of v1, f of v2 and so on f of vk. Then we can say that the cycle is exists of same length. See here, v1 mapping is f of v1 in the other graph, v2 is mapped to f of v2 and vk is mapped to f of vk. So this is the way the conditions, all these four conditions are going to be satisfied. Then we can say that the graphs are isomorphic. So not only these four, and we are going to discuss in the next coming session. In this session only, we are going to discuss. So with apart from these conditions, there are some more conditions are there which satisfies the isomorphic conditions. So here the first conditions are number of vertices must be same in both graphs, and the number of edges must be same in the both graphs, and next another one is the degree sequence must be same in the both graph, and any cycle is exists of length k which is going to be formed by the vertices v1, v2 and so on vk in one graph. Then the image, that means the another graph, there is a cycle of length k is exists with the images, that is the imaged vertices, that is f of v1, f of v2 and so on f of vk. So these are the conditions. Then we can say that whenever satisfies, then we can say that both graphs are isomorphic to each other. Now see here some of the important points. Now the above four conditions are necessary conditions for any two graphs are said to be isomorphic. So whatever the conditions we are going to discuss, so those conditions are necessary conditions to say that two graphs are isomorphic. They are not sufficient conditions, they are not sufficient to prove that the two graphs are isomorphic. If all four conditions are satisfied, even though the graphs are not isomorphic, surely you cannot say that the graphs are isomorphic. So, however, if any condition violates, then it can say the graphs are surely not isomorphic. Among four conditions, if any condition is not satisfied, then we can say that directly itself, which is not isomorphic. Suppose all the conditions are satisfied in some cases, so the graphs are need not be isomorphic, and then it has to satisfy the sufficient condition. So then only we can say that the graphs are isomorphic. Then what are the sufficient conditions? So here the sufficient conditions, when we say that we prove that the graph is isomorphic, so one sufficient condition. See here, there are three conditions will be there. Any one of these conditions are satisfied, not necessary all. Any one of these three conditions are satisfied apart from the above four conditions, then we can say that the graphs are surely isomorphic. So here, two graphs are isomorphic if and only if their complement graphs are isomorphic. the complement, whatever the graph will be there, if we are going to consider its complement, then first graph G, if I am taking, G1 I am taking, so we are going to consider its complement. So G1 bar. G2 is another graph. We are going to consider its complement. Z2 bar. Z2 bar. So the two graphs are said to be isomorphic if and only if their complements are isomorphic. Complements are isomorphic. Next, another one is any one of these three. Two graphs are said to be isomorphic if their adjacency matrices are same. Adjacency matrices are same. Two graphs are said to be isomorphic if their corresponding subgraphs obtained by deleting some vertices of the graph and their corresponding images in the other graphs are isomorphic. So whatever the subgraphs, two graphs are said to be isomorphic if their corresponding subgraphs obtained by deleting some vertices of one graph and their corresponding images in the other graphs are isomorphic. So these are the sufficient conditions. Once again, among these three sufficient conditions, any one sufficient condition is satisfies apart from the necessary conditions. Then we can say that the graphs are isomorphic. So here, two graphs are isomorphic if and only if their complements are isomorphic, and two graphs are isomorphic if their adjacency matrices are same. Adjacency matrices are same. Or two graphs are isomorphic if their corresponding subgraphs obtained by deleting some vertices of one graph and their corresponding images in the other graph are isomorphic. So once again, so what are the necessary conditions? So here we can say that G1 is one graph and G2 is another graph, and F is defined from Z1 to G2. That is vertices of G1 to vertices of G2. So that is V1 to V2, such that F1 is 1 to 1 and R2. And for every pair of vertices, if you are going to consider from V1, then the edge will be there connecting between the pair of vertices, then its corresponding image also will be there in the E2 of the other graph. E2 is nothing but the edge set in G2, and E1 is nothing but edge set in G1. Edge set in G1. So this is mathematically we are saying, or equivalently we can say that the number of vertices in both graphs must be same, number of edges must be same, and the degree sequence will be the same, and any one graph which is a cyclic axis formed with the corresponding vertices V1 to V2 and so on, Vk, then its images are f of V1, f of V2 and so on, f of Vk in the other graph. With these images, definitely there should be a cycle is formed in the other graph of length same k. Then we can say that the graph is isomorphic to each other. So directly we can say that among these four conditions, any one condition is not satisfied, then we can say that directly they are not isomorphic. So if some cases, if all four conditions are satisfying, even though graphs are not going to be isomorphic. So the sufficient conditions we have to verify. So sufficient condition means any one of these three conditions we are going to verify. Then if any one is satisfied, then we can say that the graphs are isomorphic to each other. Now let us go for one problems. Let us say G1 is one graph, G2 is another graph. So G1, how many vertices it is having? Which is having, let us say, V1 vertices and E1 edges. So number of vertices in this are 4, and here how many edges? 1, 2, 3, 4, 5, 6 edges. And G2, which will have, let us say, number of vertices are V2, number of edges are E2, then number of vertices are 4 and number of edges are 4, 5, 6. So we can say that number of vertices in G1 in G2 is equals to 4, and the number of edges in E1 and in G1 and G2 is equals to 6. So we can say that, we can say the first condition is number of vertices. Number of vertices are same. Then the second condition, if I am going to consider number of edges in G1, what is the number of edges in G1? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So, number of edges, suppose, see here. So, here, let us just 1, 2, 3, 4, 5. If I am going to consider, let us say, I am going to remove this, and the number of edges are 5, let us say, for example now. So, number of edges in graph G1 is 5, and the number of edges in graph G2 is 6. So, number of edges are not equal, so the graphs are not isomorphic. Suppose, if it is having the same number of edges, then what is the situation? We are going to discuss in the next problem. Okay. So, here we are going to remove any one of the edge. Let us say, I am removing this edge. So, which is this is formed like this. So, now the two graphs are not isomorphic. Now, let us go for G1, G2, G3. So, first condition is how many vertices these three are having. Now, we are going to verify whether G1 is isomorphic to G2 or G1 isomorphic to G3 or G2 isomorphic to G3 or G1. We are going to find this. So, first one is G1, how many vertices it is having? 4 vertices. Let us say V1 and E1. Then this is V2, E2. Then this is V3, E3. How many vertices it is having? This is having 4 vertices. This is having 4 vertices. This is having 4 vertices. So, G1, G2, G3 are having the same number of vertices. So, first condition is satisfied. Then go for the second conditions. How many number of edges in G1, G2, G3? So, how many number of edges will be? 1, 2, 3, 4, 5. So, 5 edges here, 5 edges. Here 1, 2, 3, 4, 5. This is also having 5 edges. This is 1, 2, 3, 4. So, this is 4 edges. So, now G3 is not isomorphic to G1 as well as G2 because it is having only 4 edges. It is having only 4 edges. So, G3 is not isomorphic to G2 as well as G1 because condition 2 is not satisfied. Condition 2 is not satisfied. So, the graphs G1 and G2 are same number of edges. So, condition is satisfies for G1 and G2 only, and G3 it is not satisfied. So, we can say that G1, G2 and G3 they are not isomorphic. So, G3 is not isomorphic to G1 and G2. Now, we are going to verify whether G1 and G2 are isomorphic or not. So, for that, we are going to verify whether G1 and G2 are satisfying the further conditions. Now, the condition 3. What is the degree sequence? So, here, I am just taking, this is V1, I am just taking V2 and V3 and V4. What is the V1 vertex degree is 3 and V2 vertex degree is 2. What is V3 vertex degree is 3 and V4, this is V1, V2, V3 and V4. V4 vertex degree is. So, what is the degree sequence ascending order? We are going to represent this 2, 2, 3, 3. So, for G1. And for G2, what is, let us say, this is U1, U2, U3 and U4. So, what is U1, U2, U3, U4? So, U1 degree is 3, U2 degree is 3 and U3 degree is 2 and u4 degrees to, what is the degree sequence? 2, 2, 3, 3. 2, 2, 3, 3. So, G1 degree sequence and G2 degree sequence are same. So, now the third condition is also satisfied. So, this is the degree sequence of G1 and G2. So, condition 3 is also satisfies. Now, we are going to verify condition 4. So, now, any cycles are going to be formed. Any cycles are going to be formed. So, here, both graphs contains 2 cycles of length 3. Of length 3. See here, this is one cycle and this is another cycle. So, what is the cycle length is? Cycle length is 1, 2, 3. And here also cycle length is 1, 2, 3. So, here also the same thing. Cycle length, we are considering it as 3 here. Here I am going to consider the cycle length is 3. Cycle length is 3. So, the condition 4, both graphs contains 2 cycles of length 3 formed by the vertices having the degree sequence 2, 3, 3. 2, 3, 3. So, here 2, 3, 3 means let us go for this is 2 and this is 3 and this is 3. So, like that we are going to get the both graphs are having 2 cycles of length 3. Now, the 4 conditions are satisfied. 4 conditions are satisfied. Now, so here and may be isomorphic. We can say that G1 may isomorphic to G2. So, all 4 conditions are satisfied. Then, that means all the necessary conditions are satisfied. Then, we go for the sufficient condition. We go for the sufficient condition. Now, we are going to check the sufficient condition. So, first one is their complements are also isomorphic to each other. Their complements also isomorphic to each other. So, here, what is the complement of G1? What is the complement of G1? So, whatever the graphs are exist, whatever the edges are, see what the complete graph if you are going to consider. So, I am going to consider a complete graph. Let us say, this is the graph is given. G1 is I am taking, Z1 is like this. It is given. So, what is that? G1 is, okay. So, we are considering it as like this. G1. Now, we are going to find out what is the G1 complement. So, this is Z1 and the complete graph with 4 vertices, which is nothing but, let us have, this is the complete graph with 4 vertices. So, that means from any vertex, they're connecting 2 other vertices, there are edges. There are edges. So, this is a complete graph. This is a complete graph. So, complement means whatever the edges will be there in the existing graph, then those edges we are going to remove from its complete graph, So, this is the complete graph of 4 vertices, So, I am going to consider what about its complement. Its complement is 4 vertices I am just taking. Now, this is exist here. Here I am not going to consider. And here I am not going to consider. This edge is there here. This edge is there here. And this edge is there here. So, all there except this edge is not there. So, this is nothing but G1 complement. G1 complement. So, whatever the edges will be there in the given graph, that should be eliminated from the complete graph of 4 vertices, then we can get the complete graph. We can get the complement of Z1. So, this is G1 complement. In the same way, G2 complement is only, here observe this edge is not there. In the complete graph, this edge will be there in the complete graph, but whereas here, this edge is not exist. So, the complement is this edge will be there. Now, observe this. So, this is having 4 vertices and this is having 4 vertices. Number of vertices are same and number of edges are same, and there is no degree sequence if I am taking 1 only, 1, 1, and remaining all are zeros, and there is no cycle formation. So we can say that this G1 bar is isomorphic to G1 bar is isomorphic to G2 bar. That means complement. So complement of G1 and the complement of G2 are isomorphic graphs. Isomorphic graphs. So we can say that G1 and G2 are isomorphic. G1 and G2 are isomorphic. So whatever the conditions, whenever if you are going to verify the two graphs are said to be isomorphic, we are going to verify the necessary conditions and but also the sufficient condition to say that the graphs are isomorphic to each other. The graphs are isomorphic to each other. Among three conditions, any one is sufficient. Now, the next problem. So here, two graphs are given. Now we have to verify. We have to verify whether these two graphs are isomorphic or not. Two graphs are isomorphic or not. So here, once again, 1, 2, 3, 4, 5, 6, 7, 8. So 8 vertices are there. Both are having 8 vertices are there. So condition 1 is satisfies. Then condition 2, how many edges it is having? Both are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is having 10 edges. And here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 edges. So both graphs are having same number of edges. So condition 2 is also satisfies. Now condition 3. Condition 3, we have to verify what is the, let us say, 1, 2, 3, 4, 5, 6, 7, 8 are the vertices. Now, what is the degree of vertex 1? So degree of vertex 1 is a 3. Degree of vertex 2 is only 2. Degree of vertex 3 is 3. And the degree of vertex 4 is only 2. And the degree of vertex 5 is only 2. And the degree of vertex 6 is 3. And the next degree of vertex 7 is 2. And the degree of vertex 8 is 3. So what is the degree sequence is? 2, 2, 2. Ascending order we are going to write. 3 2's are there. 4 2's are there. Let us say 4 2's. And the remaining 4 are 3. 1, 2, 3, 4. 3, 3, 3, 3. This is the degree sequence of V1. And similarly, degree sequence of V2, we have to calculate. And both are having the same degree sequence. So here I am just taking, let us consider V1 and V2 and V3 and V4, V5, then it is V6, then it is V7, then it is V8. Similarly, if you are going to calculate, then the degree sequence will be the same we are going to get. See here, degree of V1 is 3, degree of V1 is 3, then degree of V2 is 3, and the degree of V3 is only 2, and the degree of V4 is only 2, and the degree of V5 is 3, and the degree of V6 is 3, degree of V7 is 2, degree of V8 is 2. So both degree sequences are same. So the condition 3 is also satisfies. Now the condition 4. So both graphs are having cycles of length 4. Both graphs are having cycles of length 4. So here the G2, see here G1 degree 3 vertices forms a cycle of length 4, and G2 degree 3 vertices do not form a cycle of 4 vertices. So here let us consider. So here it is a cycle, and this is a degree 3, and this is the degree 3. These two are vertex degree is 3. So they are adjacent. So here it is a form vertex degree 3 are formed a cycle of length 2, cycle of length 4. And here, and if I am going to consider these are adjacent, and here these are not adjacent. These are not adjacent. These are not adjacent. So that is the difference between these two graphs. So these two graphs are not said to be isomorphic. So here these two are adjacent to each other. Here there is no such case exist. So here or else we can say that degree sequence here 1, 2, 3, 4. This is 3, and here it is a see G1 degree 3 vertices form a cycle length 3, and a degree 3 vertices does not form a cycle of length 4. So and are not adjacent. See here it is, this is important. Now are not adjacent. So we can say that the graph is satisfies all the above three conditions, but adjacency is not preserved. So we can say that the two graphs are not isomorphic. Two graphs are not isomorphic. Let us, we are going to verify some more examples. Let us, I am going to take one graph is like this. So I am going to consider a graph is like this. So we have to take so this is, let us say, A, B, C, D, E. Let us, I am just taking, this is the graph Z1. And now I am going to consider another graph. Let us say this is A dash, then this is C dash, this is D dash, and which is E dash. And now let us, we are going to discuss E dash. Let us say E dash is like this. And next B dash is the another vertex. Let us, I am going to consider another graph G dash or G2 or let us say G dash. See here there are two graphs will be there. First graph, how many vertices it is having? 1, 2, 3, 4, 5. Number of vertices equals to 5 in G1. And the number of vertices in G2, 1, 2, 3, 4, 5. So number of vertices are 5 in G2 also. So the first condition is satisfies. And now the second condition, how many edges it is having? So 1, 2, 3, 4, 5, 6, 7 edges. Here 1, 2, 3, 4, 5, 6, 7 edges. So number of edges are 7 in both graphs. So second condition is also satisfied. What is the degree sequence? Degree sequence, if I am going to consider degree of A equals to 2, degree of B is 3, degree of C is also 3, degree of D is also 3, degree of E 1, 2, 3. So degree sequence is 2, remaining all 3. 1, 2, 3, 4, 5 vertices. So the degree sequence is 2, 3, 3, all are 3s. 4 and then it is 5. 1, 2, 3, 4 and 5. So this is the degree sequence for G1. And G dash degree sequence is 1 is A dash is 3 and next B dash if I am taking 3 and C dash I am taking 3, D dash I am taking only 2 and E dash we are taking 3. So degree sequence is also same. Degree sequence also same. Now how many cycles are going to be get here? So this is one cycle of length 3, this is another cycle of length 3, this is another cycle of length 3. 3 cycles are formed. So here also 1, 2, 3. So the 4 conditions, whatever the necessary conditions are there, all the necessary conditions are satisfied. Now we are going to verify the sufficient condition. Now we are going to verify sufficient condition. And here we are just going to give the mappings of this. So here we are going to consider, let us say, the adjacency matrix of the given graph G. What is the adjacency matrix of the given graph? A, B, C, D and E. And this is A, B, C, D, E. I am not going to take the complement. Complement also you can consider, no problem. From that also you can get directly answer. Complement also we can consider. So complement, already we solved one problem. Anyhow, we are going to take the complement also for this. And instead of that, we are taking the adjacency matrix of that. Of course, we are going to take the complement of G1 and G dash, and we can find the solution. And now, here what is the AA will not be there as a self loop. So we are going to consider it as 0. Then AB is there and AC, AB is there, AB is there, AD is there. So AB and AD. And next similarly, AC is not there, AE is not there. Then another one is BA. AB is there means B is also there. Then so from B, so EC, from B, EC, E is there and C is there and E is there. So we are going to construct. So like that we are going to construct the adjacency matrix as 0, 1, 0, 1, 1. And now D, 1, 0, then 1, 0, 1. Then E, 0, 1, 1, 1 and 0. Let us, I am going to map the function. What is the mapping is? I am just taking, let us say function G is from G to G dash, and I am going to write, I am going to define the images as, let us, I am just taking f of A is equals to D dash and f of B is equals to A dash and f of C is equals to and B dash and f of D is equals to C dash and f of E is equals to E dash. See, let us, I am just considering in this way, or else whatever the rows and columns, whatever the columns or rows which are equal, so accordingly after constructing the adjacency matrix of G dash, also you can map, so A is mapped, whatever the column you are going to get, the same column, so that is going to be mapped, then we are going to get it as D dash. So directly I am taking that. So I am going to write first one is D dash, A dash, B dash and C dash and E dash. So in that same way, because I can construct n factorial ways the augmented matrix, whatever the graph is having a number of vertices. So many I am just going to change. So here I am D dash, A dash and B dash and C dash and E dash. So if I am taking like this, then I am going to get the same matrix. So 0, 1, 0, 1, 0, then 1, 0, 1, 0, 1, 0, 1, 0, 1, 1, next 1, 0, 1, 0, 1, next 0, 1, 2, 3 and 0. So in whatever manner that you are going to construct adjacency matrix of G dash, so columns if are equivalent, then mapping you assign accordingly. Then A of G is equivalent to A of G dash. That means adjacency matrices are same. So we are going to call these two graphs are isomorphic to each other. Or else if you are going to consider the complements, So here A to D is there, B is there, C is, there is no edge, A to E is no edge, and A to C is no edge. Let us say I am just taking A, I am taking A, this is one vertex, and another vertex is D, and another vertex is B, and another vertex is C. So now A to D, A to B, already edges are there. Then in its complements, those edges will not be there. So we have to consider AE, which is not exist, and AC is not exist. AC is not exist. I am going to get a complement of the given G1 complement is this. G complement is this, G dash. Now G's complement is this. So now, this is, see here, A to B edge is there, A to D edge is there. Remaining edges are not there. Now similarly B to E edge is there, B to A edge is there, B to C edge is there, B to D there is no direct edge. B to D there is no direct edge. And similarly C to B is there, D is there, E is there, C to A directly we are connecting. And similarly D to B. So this is the complement. Now G dashed complement we are going to take. G dashed complement. Now here G dashed complement from A dash. See here, observe this. A dash to B, D dash is there, B dash is there, and E is there. But A to C, there is no direct edge. So I am going to connect. A to C I am going to connect. So here A dash, let us say, and next D dash, and next C dash, and I am just taking D dash here, and another one is E dash, and another one is B dash. So A dash to C dash, there is no edge. So I am connecting in its complement. And next B to D dash, B to D dash, there is no edge. B dash to D dash. So I am going to connect B dash to D dash. Then the remaining is E dash to D dash, E dash to D dash, there is no edge. So connect this. So connect this. And now the remaining thing. So this is the complement of the given graph. D dash to A dash, C dash will be there. So D dash to E dash will not be there. So I am connecting E dash and there. Now, so similarly now equal number of edges will be there. Equal number of vertices will be there. There is no loop and degree sequence is also satisfies. Then we can say that G1 is complement. G1 bar is isomorphic to G2 bar. G2 bar. Moreover here, see here just you observe this A dash. So what I am taking, A is, let us take A degree is what? A degree is 2. And now let us D dash degree is 2. So I am going to map A to D dash. A to D dash. Next, what is a B degree is 1. B degree is 1. Then A dash degree is also 1. So I am going to map these two. Next, C and C is mapped to B dash because it is 1, 1 only. Like that I am just mapping, and from that mapping we can construct the adjacency matrix in this way, or else you construct in any order the adjacency matrix. Then whatever the columns you are identically equal to A of G, then you are going to assign the mappings in that way. You are going to assign these mappings in that way. So it is just by constructing the adjacency matrix, we can say that the graphs are isomorphic, or by taking the complements of the graphs, we can say that the graphs are isomorphic to each other. So here the given graphs G and G dash are isomorphic to each other. So this is the we covered some of the problems which are related to the isomorphic today's class. With this, I am just concluding. In the next session, we are going to meet. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.